Bootstrapping is a method to test for uh, significance of the parameters of our model, and it uses a brute force method. It is a brute force method of repeated resampling. Okay. Now, what happens in bootstrapping is you will always have to specify the number of bootstrap samples. Okay. So for example, I told you we will specify 5,000, right? So this is an input that you will always have to give to the software. Now, what happens in bootstrapping is we had a original sample which was of 557 elements, right? This was our sample. Okay, this was the original sample. Now, what the software does is it creates 5,000, depending on you gave that input as 5,000. So the software is going to compute 5,000 bootstrap samples, each of the size as the original sample. So it is going to create bootstrap sample 1, bootstrap sample 2, bootstrap sample 5,000. Okay. Now what it does is you had some data here 5, 4, 3, 2, 1, 5, 4, 1, 1, 2, 3, 4, right? Now what it does is basically it starts random sampling and it starts pulling in data into, so it assumes that this original sample is the population and it starts to sample elements from your original sample into its bootstrap sample. And what it will assume is that, and it is repeated resampling. That means the same element can figure multiple times in the same data set, in the same data, right? So it is not that if I have sampled 5 once, I cannot sample it again. I can put it back in the sample and then again pick it and fill my bootstrap sample. So it will create from the original sample, it will create these 5,000 samples. Then what it does, it fits your model, the model that you have created, right? This model that you have created, it fits your model on each one of these samples. Okay. And it will get A 5,000, B 5,000, and C 5,000, right? So basically, it will estimate this model on the first sample. It will get a value of A1, B1. It will estimate this model on second sample. It will get a value of A2, B2. It will fit your model on the 5,000th sample that it has created, and it will get a value of A 5,000 and B 5,000. Similarly, it will compute A1 times B1 also of the indirect effect, A2 times B2, and A 5,000 multiplied with B 5,000. Now what it will do is, in order to test whether your, for example, if we want to test whether this hypothesis, the indirect effect is significant or not significant, what it will do is it will arrange these numbers in ascending order. So the A into B product, which was the smallest, to the A into B product, which was the largest. Okay, so it is the first value, second, third, fourth, fifth, sixth, up till, or let me make it even closer because I want to write something more here. So let us say A1 to 5,000. So it has arranged these 5,000 numbers on in an ascending order, right? So they are increasing in magnitude from smallest to largest. Now you say, I want to test 95% confidence interval. Okay, I want to see what is my 95% bootstrap confidence interval. So what it will do is 95% means on the lower side 2.5%, on the upper side 2.5%. This is 2.5% and this is 2.5%. So it will find the cutoff, the lower bound, right? So this will become the lower bound of the bootstrap confidence interval. This will become the upper bound of the bootstrap confidence interval. So what is going to be the lower bound? 2.5 divided by 100 into 5,000, right? So you will get, what will you get? You will get 125th value here. You will get this, whatever is on the 125th position will be the lower bound. So basically you will get the lower bound of A into B here, whichever is on the 125th position. Similarly, what will this be? This will be, the upper bound will be 4,875 plus 1th value on the right. So this value is going to become your upper bound of the confidence interval. So if, for example, here this value, whatever was on the 125th place was, let's say it was 0.01 and here it was 0.10. So you will say my 95% bootstrap confidence interval ranged from 0.01 to 0.10. What did you want to check? You wanted to check for 0. Now 0 does not lie in this interval, in this 95% interval, and therefore I can say with 95% confidence that my indirect effect is significantly different from 0, and it will therefore be therefore in this model I have significant mediation. So this is what it is essentially doing. It is creating multiple models, okay, and the only assumption in the, it does not make any assumption about normality in testing for your for the significance of your coefficient. The only assumption is that your original sample, the only assumption is in bootstrapping here is that your original sample is good, because it is going to consider that as the golden sample, and from that it is going to create 5,000 samples, and that on that it is going to perform the analysis and then compute, right? So you need to factor or keep that in mind, that your original sample should be good. After that, this can be used to test your coefficients also. You can test whether your, what is the significance of your individual coefficients and also of your indirect effects. right? So this is a method that is useful for testing the data or parameters, significance of parameters when you have non-normality or when you have or when you are testing for mediations.